It is 2 hours UTC, and here we are, Astronomy Daily Live. Hey, everybody. You can call me Cosmic, and welcome again to the ever growing circle of friends coming in and sharing a common passion. And I'm going to pull up my chat here on my Linux machine like that. And oh, you know what? Tweet. I want to tweet. So hold on one second. I'm going to try to do this. I'm going to try to do this one-handed with one hand tied. Oh, tied behind my back. Oh, I gotta put the mic down. Hold on. All right, there we go. There we go. I'm doing it. I'm doing it. I'm copying. I'm pasting. And I want to put up a little graphic. Always like to put pictures up if I can. Let's do this one. Let's do that. Let's do a different one. Let's do this one. There we go. There we go. So I hope everybody's doing well today. Everything is okay here. I took a little pause from doing my characterization of my telescope system here behind me, telescope and CCD. Um, just I wasn't getting the joy that I thought that I would get, and little things in the back of my head um, say things like something's not right, something's not right, something's not right, and I uh, I've I'm I've learned to trust that kind of um, intuition and go with it. And usually I would say I would definitely for sure say that more than half of the time um, those intuitions sort of ring true, at least eventually. So you know what what I was getting, the chatter in the back of my head was, you know take a break, um, for a couple of days, look at this with some fresh eyes in a little while, and see where you are. And so I did that, and when I got home from work today, I started taking a look at it again, and yeah, there's some things in there are that are definitely setting up some red flags. So I had to stop. I had to stop to do this live stream. So this live stream is just totally interfering now with my very important work. So I just uh, yeah, it's just really rude. So yeah, I am so glad to be here every single day, sharing the passion, talking astronomy. I love all the retweets. Thank you very much. I think that's very awesome. Um, I like the support. Um, I think the support is going to grow because this is just fun, right? It's just fun. it's like an adventure, and you know, you never quite know where this adventure, this path, is going to lead, right? Because it's a windy path and you can't see very far ahead. It's just, you know, that's science for you. That's science. You're just, you know, completely in the dark, right? I mean, and I mean that figuratively and literally, right? We're just being in astronomy. We actually like to be in the dark. So yeah. Um, hopefully something's um, um, going to come out of this sort of latest series of um, intuitions that hopefully I'll be able to find an explanation for, and get to the bottom of things a little bit. A lot of it just has to do with my code, right? I'm I'm writing um, most of my own code to analyze this data, get, you know, the photometric measurements out of it, and you know, me being a human code writer, that's a just a nasty combination. so so yeah, cheers. I got the coffee tonight. Cheers. So over on my Discord server, which you can find a link to down in the description, Tom um, posted a little um, article uh, mentioning the fact that this weekend is. I did, Uncle Bill. I did tweet. I did. I think I beat you to it. Um, but Tom mentioned what's the exact. I'm gonna pull it up here on my Discord server. I'm gonna actually do it over on my Linux machine so you can't see it. Spring Astronomy Day 2018. Spring Astronomy Day. And so uh, just FYI, if you don't already, or if you aren't already aware of some kind of a local event that is going on, you might want to look around a little bit, see if there is anybody who is doing a little star party, either Friday night, Saturday night, Sunday night, or um, or looking at the sun. So I don't think that the sun is very active at the moment. Let's see, I've got some messages over. Yeah, thanks, Uncle Bill. you know, uh, uh, I will forget to tweet, and I think that's, you know, every channel, every live stream has its own, you know, character, its own personality. So you know, forgetfulness is part of me and is going to be a part of this um, channel as well. It's sort of, you know, the absent-minded professor, right? Right. It's just you know, some things it's um, just going to get away from me. So just have to put up with it. You know, whatever, whatever. It's cool. Um, greatly appreciate the reminders, though. Keep those up because if if I can, you know, remember to tweet every single day, I'd be happy to do that. So, but anyway, so apparently this is um, spring astronomy weekend. So, you know, look around, see if there are any events in your local area. as I said, star parties at night. So that's where um, uh, one or more telescopes will be set up at maybe a dark site, and you can go around and look at all the different objects in each of those scopes, and that's a lot of fun. And it's for me for me it's a lot more fun to actually be showing people things than it is to be looking around. I've I I don't think that I've ever been to a star party where I didn't have my own scope there. So, and running my own scope, can't remember if I ever have or not. If it is, it's extremely rare. So I'm usually at my scope, and what I try to do at these star parties is sort of show the kinds of objects that are off the beaten path. Okay, everybody wants to point to the moon, and everybody wants to point to planets, and everybody wants to point to sort of the more common objects, right? But so I'll being the way I am, um, I will try to find uh, the overlooked object, the object that doesn't get a lot of attention. Maybe even a more challenging one to actually see. So even somebody who has never looked through a scope before, right? Maybe I'll try to find some kind of faint galaxy, and really get them to understand um, uh, what they're working with and what they're dealing with, and that what you see through the telescope with your own eyes is practically nothing. It's practically nothing like what you're going to see in photographs, that either people have taken from the ground, or like um, um, HST types of images. It's going to be nothing like that at all. And you know, a lot of the reaction is disappointment, right? It's like, is that it? Is that it? And it's like, yeah, that's it. That's it. And you know, one one can, and I have said, but look, okay, consider what you're seeing, and then I get into the numbers, right? And that sometimes makes them feel a little bit better, right? Because this galaxy is, like 100 million light years away, and what you're seeing there is, a hundred, you know, um, maybe half a trillion stars, right? And so you start throwing those kinds of numbers around, and that can impress and sort of take the edge off the disappointment, right? But uh, that kind of disappointment um, is cultivated by these fabulous pictures that are constantly being thrown at the general public, and not necessarily realistic, right? Um, so there's really nothing that can be done about that kind of disappointment. It's just, I mean, it depends on the person, and um, most people, right, when they see a little faint galaxy that they like really have to try hard. Maybe they actually have to use what's called averted vision. Okay, and what that is you actually look off to the side of the field of view, but you sort of concentrate on where that faint object is. It turns out in your retina there are these different cells that are called rods and cones, right? And cones are sensitive to color, and rods are sensitive to brightness. And so, right in the center of our field of view, where we normally look and concentrate, are a large number of rods and cones, right? But off to the sides of that central area, there are less cones and more rods, and so we're more sensitive to light if we look um, off to the side. And so when you do that, oftentimes these little faint fuzzy things will all of a sudden, just sort of pop out. Now that's sort of a relative thing too, because it's still really, really faint, really, really small. Um, but they definitely will appear brighter, for sure, for sure. I mean, uh, uh, that's just a common thing that's done with visual observers. When you're looking through a scope, look off to the side, concentrate on where the object is, and it will pop. It will pop a lot more. So, maybe by a factor of 2 or so, it's pretty significant. Anyway, so that's sort of what I like to do. I like to show people, I guess, what you'd call a more realistic example of what you're typically going to see if you get into sort of the amateur side of this, with the telescope and observing objects. So, I let others look at the moon and look at planets and all that, and I try to focus on not the impossible things, but I'll pull up a galaxy, right? I mean, I'll pull up a bright galaxy and look at that, and yeah, most people are disappointed, and it's like, he's not showing anything interesting over there. But some people are like, wow, really? Is that what that is? They get it. They get it. And if somebody can get that, then they're probably hooked, right? Um, um, Now, most definitely, astronomy is not for um, everyone. I don't I don't I don't really agree with this thing that everybody should be involved and everybody should be excited. I don't think that's how the world works. I'm not excited about everything. Uh, but there are people who are like incredibly intensely excited about things that I find to be just sort of like, right? And I think that's great, right? I think that's what makes a very interesting and exciting world, is that we all, you know, have a passion for different things. And so my thing here, with this live stream, is not this huge net. I'm not trying to cast this huge net and get everybody really excited about astronomy, and everybody has to be, really passionate and everything. No, 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 no. I want my core, right? I want 100 people. I want 200 people who are just as excited about this as I am, and um, I'm not really interested in casting this huge, huge net. Now, because I'm on YouTube and social media and all of that, that net is going to be cast, and uh, but who actually stays um, in that net is going to be a very, very, very small uh, um, part of that. And I am not interested in necessarily getting people excited about this at all. Um, uh, that's sort of a side effect. My thing is that I am sharing a passion, and that's it, right? And if it rubs off and somebody else gets the bug, cool, very, very cool. Now, I have not been paying attention to my chat at all. So astronomy day, yay. Personality indeed, yeah. Forgotten tweets here would be like Easy Linux channel, not CLI typos. Um, yeah, Space TV, if you're still on, yeah, I think that's exactly it. It's um, it's just a physical reality of our eyes, and it's just a little trick that one gets told, right? That that's the kind of thing, the averted vision trick. That's the kind of thing that I think would be sort of hard to stumble upon. Um, maybe people realize it and don't really understand, what's going on. But that's it. It's just rods and cones. It's just the nature of our eyes, right? Um, anyway, but I really really enjoy star parties, public ones especially, um, because you get a lot of new people and kids, of course, who have never looked through a telescope ever, 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 and so it's very very cool. It's very very cool. It's very very fun, and uh, you know gets people excited, um, interested, and yeah, I think it's awesome. Uh-oh, I think I have a cat situation. Let me be right back. Hold on. All right, crisis averted. Crisis averted. Let's see. I'm going to go back to this, and I'm going to go back to that. There. So now I'm watching my live stream. Thank you. Appreciate that. So I'm going to keep this live stream a little bit short tonight. So let's just do a an object of the day, right? An object of the day. So I'm going to share my screen, and what are you doing, cat? I've got some strange kitties here. So just wanted to make you aware again of this awesome site called archive.org, right? And it's ARXIV. The X is supposed to be like the Greek letter chi. So it's archive.org, ARXIV.org. And this is just a clearinghouse for scientific papers. Um, and as you can see, all different kinds of physics, nuclear physics, high energy physics, astrophysics, mathematics, computer science, biology, finance, stats, electrical engineering, economics. So these are all the latest and greatest sort of bleeding edge um, research in all of these areas. And you know, I I just look at the astrophysics one. That's all I really ever look at. Um, but there's so much more here. It's absolutely amazing, right? And so these are updated every single weekday at about 1 hour UTC or so. And you usually get between, I don't know, 20 and 50 new papers every single day. Every single day. So I'm not going to get into this much, but this is just to show, sort of an example of what we're talking about. So these are, professionally written um, papers um, that are going to be. Look at what this kitty did. What did this? I've got a wild kitty in here. I don't know what just happened. She's walking all over my keyboard. All right, there we go. um, so yeah, these will be published sometime in the future. Oh yeah, just on and on and on and on and on, right? But anyway, I'm just giving a plug again to archive.org. All these papers are free. You can just click on the little PDF links here, and you'll have full access to the paper itself in just a PDF form, right? I'll upload one here just so you can sort of see this. I'm not gonna get into this now. Of course, I click on a paper that's probably 800 pages long because it's taking a million years to load. Just just a slight exaggeration there. Man, this must be a big paper. 22-page paper. Yeah, yeah. So, here's just full access to lots of pictures and everything. I don't know what this is. Wow, it's wow. Yeah, lots and lots of pictures. I love pictures. All right, enough of that. Let's do a I don't know, what should it be? Uh never understood that X before. X, what X? X? Sorry, Uncle Bill. My density precedes me. X, that X before. All right. Anyway, let's see. Should we do NGC or Messier tonight? Oh, let's do Messier. Okay, so there's 110 Messier objects. So I'm going to generate a random integer between 1 and 110. So drum roll, please. M33. M33 is a beautiful, beautiful spiral galaxy in the constellation of Triangulum, and it's one of those Messier objects that is really, really great to sort of test the darkness of your sky. If you have a very, very dark sky, the thing about M33, and we'll take a look at it here in more detail here in a second. Oh, archive. Gotcha, gotcha, gotcha. Yeah, yeah. It's supposed to be the Greek letter chi for which is an X, right? So yeah, yeah, yeah. That's what that is. Um, so uh, M33 is what's called a low surface brightness galaxy, and that's mainly because it just uh, um, its apparent size is pretty large, meaning that it's spread over a large area, and it's sort of a face on galaxy. So, all of its light is just spread over a large area, and so the surface brightness uh, is just very, very low, and so it's not much brighter than the background sky, and so seeing it without a telescope or binoculars or something is challenging, right? You need a really, really, really dark site where your background sky is really, really dark. Of course, where I am out here in southeastern Arizona, it's relatively easy to see. You know, I sort of use it as sort of a measurement of haze, right? If there's a layer of haze up there, then I'm not going to see it. Um, Otherwise, it's relatively easy to see where I am. So let's go over to Simbad. Now, M33, I know for a fact, is a much studied object. But let's just get some basic information about M33. How far away it is, where it is, how it's moving, that kind of stuff. Yeah, that's what this object of the day is all about. So you can see the uh, uh, coordinates here. Right ascension, 1 hour, 33 minutes, 50.904 seconds, and a declination of positive 30 degrees, 39 minutes, 35.79 uh, seconds. Let's see. Yeah, as I said, it's pretty big, right? 29 arc minutes by 23 arc minutes. So it's about as big as the moon, right? It's absolutely huge, absolutely huge. Um, UBV magnitudes. So these are sort of you know violet, blue, and visible, right? Uh, V being actually in the green. Um, JH and K are sort of more towards the infrared. But as you can see, it's bright. It's bright in all bands, right? Very, very bright. Yeah, yeah. Uncle Bill mentions that right now M33 is pretty much right where the sun is. So when um, I'm not in alignment with, but when the sun is up, um, M33 is also up. So pretty hard to see this time of year for sure. So here's just a bunch of other names for it. NGC 598, UGC 1117, etc. These are basically just different catalogs, right? And typical names just showing the right ascension and declination of the object itself. Oh, yep, lots of references, almost 5,000 of them. So yeah, this is as I said, a much studied Messier object, relatively close to M31, right? The great Andromeda galaxy. So let's see. Let's see what its distance is and velocity. I don't know if this thing's moving towards us or away from us, relatively speaking. Okay, so looking at the velocities here, it looks like it's moving towards us, or we're moving towards it, right? I mean, it's sort of a relative thing. So everything is moving um, relative to each other. So in this case, M33 is moving towards us and that's pretty good consistent measurements here, except for a few which are really kind of strange. But if you sort of ignore those, yeah, we're looking at around 180-ish kilometers per second or so moving towards us. So, relatively speaking, that's not moving very much. So this sort of indicates, right? This is sort of an indication that probably we and it are sort of moving together, and so pretty sure that M33 is part of what's called the local group, which is uh, a cluster of galaxies that includes us um, and Andromeda, and I believe M33. I'm pretty sure that M33 is part of the local group here. And if we look at the distance measurements, again, we're seeing one outlier here using redshift 4.11 million parsecs or megaparsecs. Everybody else is around, 0.8, 0.9 megaparsecs. So I'm just going to use like 0.9. So a parsec is 3.26 light years, and there's a million of those in a megaparsec. And then like 0.9. So yeah, really, really close. 2.9 million light years away. So that is right next door. I mean, we're almost bumping into that thing, right? And that's why it looks so big, and that's why it looks so bright. Is because it's incredibly close to us. We're touching shoulders there. Yeah, for sure. For sure. I don't know what these observation logs, every single time I look at this, I say the same thing. It's like, I really need to sit back and look and see what these observation logs are. I need to do that. But let's look at the picture, see what's in the area. Of course, this is a absolutely gorgeous galaxy. You can see a lot of details in this galaxy because it's so close. we can actually see. I'm pretty safe in saying that we can probably see individual stars in this galaxy. Now, not the foreground ones, right? Not um, pretty much everything else, but I'm talking about stars in these wispy areas out here. I'm sure that we can see those. I don't know if we can see it in this particular image. Uh, Probably not all that well. Um, but we can definitely see regions, star forming regions like here and here, these clumps, right? There's these clumps. We're definitely seeing things there. I'm sure that we can see um, globular clusters, um, open clusters, all those kinds of things. But yeah, beautiful, beautiful galaxy, of course. Let's zoom out here and just sort of look in the vicinity of M33, see if there's anything else incredibly interesting. Doesn't look like there's anything amazingly interesting. Just foreground stars. So, pretty much everything else that we're seeing in this field of view, except for M33 itself, right, is a star in our galaxy. So these are just foreground stars that are obviously between us and it. M31 is, yeah, there's M31 up here. You can see that. You can sort of see what its relationship is to M33, right? There's M31, here's M33 down here, much bigger, quite a bit brighter, but awesome, awesome galaxy. Much studied. So let's go back to Sinbad here. See what it has to say about 3. Now, for sure, for sure, I am not going to scroll through 5,000 references. There is no way I'm going to do that. But I think these are ordered sort of in a temporal order. So the newer papers, the newer discoveries are going to be out here in front. So let's just let this thing do its thing here, taking its time. I don't know why it's taking as long as it is to figure itself out here, but that's I'm old enough to greatly appreciate the internet. Uh, I'm old enough to have been around when the internet wasn't, and so being able to sit here in the comfort of my own home and look at and read about all kinds of things astronomical. Oh, it's mind blowing. It is just awesome. So you'll very rarely hear me complain about this slowness of the internet. It's just in my head that kind of thing just doesn't exist. So I think it's completely awesome, that we can sit here and do this. Cosmic flow around local massive galaxies, multi-wavelength photometry, and in 42 ultraviolet microwave bands. That might be a little bit interesting just to sort of see what the pictures look like. The Dustpedia project is capitalizing on the legacy of the Herschel Space Observatory, using cutting-edge modeling techniques to study dust in the 875 dustpedia galaxies, representing the vast majority of extended galaxies within 3,000 kilometers per second that were observed by Herschel. This work requires a database of multi-wavelength imagery and photometry that greatly exceeds the scope of any previous local universe survey. Cool. We present our multi-wavelength imagery and photometry across 42 UV microwave bands for the 875 dustpedia galaxy. Our aperture match photometry combined with external supplementary photometry represents a total of, I guess that would be 21,857 photometric measurements. There isn't a comma there, but I'm just sort of assuming. All right, well, let's look at the paper. We can go to the astrophysics data system, and theoretically, there's going to be a PDF file here, probably from archive. Yay. Ooh, I'm seeing some pretty graphics already. I'm just a sucker for pretty graphics, especially when it comes to astronomical stuff. So here it is. It's slowly loading. Man, I just can't believe how slow this internet is. As I said, I think it's completely awesome that this works at all. So you'll not really hear a lot of complaints from me about slowness. All right, let's see if I saw a picture here showing, I think, all the different wavelengths and wavelength bands. Yeah. Okay, so this is the whole survey. Now, what I will complain about and what I will angst about is the slowness of computers. Okay, there is no reason for computers to be slow, but they are. So on the x-axis here, the lower axis here, is the wavelength in microns. Okay, so you sort of have to, if you're an optical astronomer, you sort of have to be able to translate this. So one micron of wavelength is, I believe it's 100 angstroms, if I remember right. Is that right? Yeah, I think so. So yeah, this is sort of hard to interpret sometimes, but 10 to the 0 microns is 1 micron. Okay, so 1 micron. Actually, one micron is 10,000 angstroms. Yeah. So here is 10,000 angstroms. Here's 10 to the minus 1, 0.1 micron. So that's 1,000 angstroms. So we're going from 1,000 angstroms here to 10,000, 100,000 angstroms, 1,000,000 angstroms. Yeah, it just goes on and on and on. This goes way into the well, as they say, it goes from the ultraviolet into the millimeter bands. So there they all are. So they've looked at these galaxies. They've measured the brightness of these galaxies with all these different filters, all these different wavelength bands. And so this is just a paper that's, presenting that information, right? So let's just go through it. 31-page paper, gee whiz. Okay, more pictures there. Let's look specifically for M33. See if it comes up here. I don't know, is it? I don't think so. I'm not hearing anything. Let's see. Yeah, so specifically, let's see. What was it? It was NGC 598. Is that right? Yeah, NGC 598. Let's look for NGC 598. 598. Yeah, I'm not seeing anything there. Oh, yeah. There it is. Let's see, is this NGC? Is this an NGC number? No, photometry. Present details. Yeah, I don't know. Details of each band for which we have data. Um, Photometry present. Uh, yeah, no, that's just a galaxy count. It's the galaxy count. So that's not quite what we're talking about here, but that's the only reference. See, this, I mean, now for some reason, this paper was referenced in Simbad. So I'm still assuming that somehow M31, I'm sorry, M33 is mentioned somehow, but it is not specific in this paper. So I don't know. Again, I'm just looking for pictures, but you know, they're just going through all the data sources, how they processed their images, how they even pre-processed um, images, foreground star removal processes. That's pretty good. Not bad. Looks, you know, you can see artifacts here, right? I mean, this is obviously where that star was. This is obviously where that star was. And so, there are um, artifacts, but yeah, I don't know, not too bad, not too bad. Sky subtraction, that's always that's always a challenge. Let's see, what are these talking about? Aperture fitting. Yeah, photometry, uh, the challenges of photometry uh, are always the same. This is the same shit that I'm going through right now, trying to say, okay, you know, uh, uh, what radius, what shape should I use in order to, get the kind of um, photometry I want. It's a never-ending thing, and it's universal, a universal challenge. Aperture photometry. That's exactly what I'm doing too. Uh, Aperture noise. Huh. So much work, goes into these things. It's really, it's mind blowing how much work goes into these papers. This is a nice long paper though too, so because they have to talk about uh, every single band, right? Uncertainty. They have to talk about how sure they are about what they're seeing. Sometimes the uncertainty is pretty high. There's more, yeah, just lots and lots and lots of plots and correlations and yeah, on and on and on. Anyway, M33 for sure is a very, very, very much studied uh, object. And if you can get out to a dark sky, for sure, do this little test. If M33 is visible, try to see it because it's pretty cool, to see. Um, and if you have a dark sky, a dark background sky, right, you should be able to see it. It's a challenge, and even through a telescope, it's challenging because it's so big, right? It's so big that I mean, um, it's as large as the moon. So you need a nice wide field of view to see it, and so yeah, I mean it's a challenge for sure, but it's worth seeing. It's very very awesome, and I think with that I am going to exit this planet for the time being. Let you guys get back to whatever you're doing, and yeah, I think for tonight I'm going to get out of here and wish you all a very, very good evening and a good day. And check again tomorrow, same time, same place, 2 hours UTC, Astronomy Daily Live every single day. Now, I'm going to break that rule. I'm going to break that rule this coming, what'll be UTC April 22nd. April 22nd at 2 hours UTC. I am not going to be here. I'm not going to be doing a live stream. I'm going to be playing a gig, right? I've got a little music festival to attend and play some some cool music, and so that particular live stream ain't happening, ain't happening at all. So that for me is Saturday night here in southeastern Arizona, United States. So, but that is 2 hours UTC on the 22nd of April. There will be no live stream, so just pre-warning. Uh, not gonna happen. I'm gonna be doing some music that night instead, sharing another passion of mine, which is all things sound. So, all right. But for now, I'm going to get out of here. I will definitely be here tomorrow, 2 hours UTC, 23 hours from now. All right. Take care, everybody. As I said, have a great day, a great evening, and I will see you on the spin. All right. Take care. Bye.